night.
Welcome back to Fabulous Factoring. We're now on part 3. And to start off this session, I would like to ask a question. What method should you always try first when factoring? I cannot ask this question enough because it's the most commonly missed part of the factoring process. Always, always, always check for a GCF first. So our steps to factoring in this order: number 1, check for the GCF. Number 2, check to see if it's D2PS. Is it a difference of 2 perfect squares? Of course, it would have to be a binomial in order for that to be true. And then the third is check to see if it's in the form ax squared plus bx plus c. This is our trinomial session tonight. We're going to look at how we get a trinomial first. So what I'd like you to do is take these 4 examples and multiply them out and tell me what you get. So if you're back with me, the first example, x squared plus 7x plus 10. The second example, x squared plus 9x plus 14. The third example, x squared minus 5x minus 24, and x squared minus 9x plus 20. It's essential that you have a really firm understanding of this and maybe have even noticed a pattern that is occurring when you multiply a set of binomials. So let's take a look at how we would go backwards from this process to finding if this was the answer. How do we know the question? Remember, when you factor, what you're trying to do is find what did we multiply to get the answer. So when we're looking at a trinomial, we have to think about how did we end up with this? What did we multiply together to get this product? How did we get this term? How did we get the last term? Now, if you've evaluated and really thought about this, you may be able to work backwards and get the x plus 5 and x plus 2. You may have just noticed that it was the first example that we did. But there is a pattern, and if you think about it, it's not that difficult. How did we get this 7 from those? How did we get the 10 from those? Well, the middle term is going to be the sum of your 2 constants, and the last term is going to be the product. So this is what we added, or in some cases subtracted, from our binomials, and this is what we multiplied from the constants in our binomials. So that's the first question. You already have that. If we look at the second question, r squared plus 12r plus 11, we have to have a product of 11 and a sum of 12. What numbers will give us a product of 11 and a sum of 12? Well, whenever you have something that's prime, it's going to be pretty straightforward, right? There's only 2 factors of 11. So in this case, we know that it has to look like 11 and 1. And then to get an r squared, it's going to be r times r, and to get a 12, we would have to add 11 and 1. Now we're going to go to number 3, which is not prime. Our constant is not prime here. So we have lots of factors of 18. We have 18 and 1, we have 9 and 2, and we have 6 and 3. And we need to know which of these give us a sum of 9. So it's obviously 6 and 3. Now you also have to pay attention to the signs. Positive 18 and a negative 9. How can I factor this so that I'm going to end up with what I want? I need to get that negative 9. So some of you may have already thought of this. I know I put the y's in my first position, and I know it's 6 and 3. The operation that needs to take place in between these is subtraction, because a negative 6 times a negative 3 is going to give me that positive 18, and a negative 6 plus a negative 3 is going to give me the negative 9. Again, you have to be mindful, you have to be observant, you have to be attentive. Moving on to the fourth problem, a squared minus 10a plus 21. Why don't you try this one on your own and see what you get for your factors? And I got a minus 7 and a minus 3 for the same reason that I had that in the previous problem. Now, number 5 is going to be a little different than the ones we've done so far because of the fact that this last term is negative. When that happens, I know the only way to get a negative 8 at the end is I'm going to have one factor be positive and one factor be negative. So I could come up with a whole bunch of different things. I could say it could be positive 1 and negative 8, negative 1 and positive 8, positive 2, negative 4 and negative 2 and positive 4. And that's a lot to write out. You can do that mentally. And you would see that in order for the middle term to be negative 2, the only one that's going to work as a sum is this. Okay? Now when I see that negative at the end, I like to think of it as I need a product of 8 and a difference of 2. Okay, and then I just think about which one has to be negative. The bigger one has to be negative. If you take a look at number 9, that one also has a negative constant at the end, so go ahead and try that one on your own. So you should have gotten x minus 10 and x plus 8, or x plus 8 and x minus 10. The key being it does matter which one's negative and which one's positive. Go ahead and see what you think you can do on the rest of these. The answers for the remaining questions, with the exception of number 12, are shown. A couple things I'd like to bring your attention to. If you look at number 6, notice that I've written it either way. The key thing here is knowing that the 7 is negative and the 1 is positive. In number 8, I've expressed this product in two ways. The x minus 7 times x minus 7, or this should be a minus. This would be x minus 7, the whole quantity squared. And likewise in number 11, you can express your answer as x plus y quantity squared. In number 12, that one's a little tricky, but I'd like you to keep that as a hot question for tonight, and we will go over it tomorrow. Have a great night.